and gentlemen, thank you for standing by and welcome to our Global Mapper webinar. Currently, all participants are in a listen-only mode, and you should be able to see Sam Knight's picture on your screen. If you need assistance or have connectivity issues during the presentation, please send an email to feedback@bluemarblegeo.com. Our support team will reply to you promptly. If you have any questions during the presentation, you can use the questions tool at the right of the GoToWebinar screen to submit questions to our panelists. Our panelists will field some of them as we go and address more at the end of the presentation. We'll address as many as we can during the presentation, and we'll follow up with you directly via email on any remaining questions. You can always email our support team at gmsupport@bluemarblegeo.com at any time. Today's demonstration is approximately 60 minutes in duration. Welcome, everybody. This 60-minute session will cover topics related to working in 3 dimensions in Global Mapper. Exploring real-world scenarios, we will examine placing models on your map or creating your own from scratch, and then viewing and analyzing the data using the 3D viewer. Workflows covered will include editing 3D data using the Digitzer, viewing 3D surfaces and models, and terrain analysis functions such as viewshed analysis, watershed delineation, creating terrain surfaces from LiDAR data or contour grids, and contour generation. Just to let you know, our sales team is on the road again. First, we're going to head off to Calgary next week. We're offering our popular Blue Marble Applied Geodesy training course. That is Wednesday, May the 16th. Following that, we'll be in Denver, Colorado the whole week of May 21st. There are 2 public training sessions being offered, and there are limited seats available. Following those 2 stops, we'll be in Malaysia for another public training course in KL on June the 5th. As always, we have custom on-site training sessions available. If you'd like to find out more, please contact your Blue Marble sales representative at sales@bluemarblegeo.com. All of this information can be found on our website, and keep a lookout in the next week for Global Mapper version 13.2 to be released. At this time, I'd like to introduce Sam Knight, Director of Product Management. Hi, Sam.
Thanks, Danielle. Good morning, everyone, and thanks for tuning in to this month's webinar for Global Mapper topics Danielle was talking about there. We're going to be taking a look at working in the 3rd dimension in Global Mapper. So we're going to be taking a look at both our sort of 2D top-down mode for interacting with things like terrain models, contour grids, LiDAR data. We're then going to take a look at that same data in our 3-dimensional viewer, where we can actually do things like pan, zoom, rotate all around in the 3rd dimension to interact with the lumps and bumps in that terrain model and all those different types of data. And then we're going to take a look at some of the specific analysis functions. So we're going to take a look at stuff like path profiling, elevation profiles, doing things like cuts and fills, lines of sight, modifications of terrain layers that we've either created or just simply load in, and some analysis functions like the view sheds, finding visibility analyses in 360 degrees around a single point. Maybe it's a structure or just somebody standing on the ground looking off to the distance, and things like watersheds. So today is basically all about terrain. This is going to revisit some topics that we took a look at in our very first Global Mapper webinar that we did a number of months ago now. Today's session is going to be recorded, so if there's something that we covered that you want to see again, you will be able to find that on our website. I'm going to point that out now, and I'm going to point it out again at the end of the session. On our website, we have a page devoted to webinars. So the main domain there is bluemarblegeo.com, and down on the left-hand side of the screen, you'll see a webinars link. You'll be able to use that link to navigate to the page. This is where we post our upcoming webinars, and at the top of the page, you'll also see that link to previous webinars, so you can see the sessions that we've done in the past. We've had a lot of interest in that since we've started the Global Mapper webinar series, in addition to our Blue Marble Desktop series. So be sure to check that out if you haven't been able to tune in to any of those previous webinars. So look for today's webinar to show up there in a day or two once we get the videos converted over to a format you can easily work with. So today we're going to be jumping right into 3-dimensional data. So I'm going to start off assuming that you are generally familiar with working around in the Global Mapper interface. Today is a little bit more of some advanced topics. If you're a totally new user and you're unfamiliar with some of the things we're looking at, you probably want to check out one of the past webinars, which was a general overview, which is an introduction to the main application itself and sort of the basic navigation. So today I'm going to jump right in. We're going to start right off by looking in our own data file. So I'm going to click that button right in the middle, and I've got a collection of data here. I have a number of different pieces of data that we're going to be working with today, but the first thing I'm going to grab onto is an elevation grid derived from what's called the ASTER data set, and that is a worldwide elevation model published by the NASA Jet Propulsion Laboratory specifically. Specifically, this is a piece of data that we do have an inbuilt on connected pieces of elevation data. So in our 2D top-down mode here, our sort of normal map view, this is a hill-shaded elevation model covering basically terrain in the area that we're located at here in Maine in the U.S. So this is basically a digital, roughly equivalent to what's called a digital terrain model. So this is a bare earth model of elevations. You'll see the shader down the left-hand side of the screen there with our elevation ranges shown and the colors being used to render the different elevations on screen here. The colors in particular in most of these are applied in the application itself. So you'll see at the top of the screen there's this little drop down, and that's our what we call our shared shader. That's what we use to color both explicit elevation levels as well as slope shading. So we can put this in some alternate views here. So we start off with our default Atlas shader. I can pop that over to our slope shade, and that gives us instead a different series of colors, and these colors are customizable. Shows us instead the intensity of the slopes. So darker areas on the map have higher slopes, and the lighter areas have slopes closer to zero. So there are different ways we can actually render those for view. And there's a number of different shaders in there that you can play around with, some commonly used shaders, depending on what your specific need happens to be. So we have a digital terrain model here. This is being stored in what's called a global mapper grid format. This is one of our own internal formats. It's fairly efficient for storing these elevations. And there are a number of other types of files that can be brought in. So we have about 60 different types of elevation grids. You'll notice our long list down the application of all the different types of data. And there's really just way too many to get into specifically, but there are about 60 different types of elevation grids that we can connect up to, in addition to some of those online data sources that I'll be coming back to in just a minute. So our regular two-dimensional mode here is sort of what we think of as more of a cartographic mode, top-down view. And then on the upper toolbar, you'll see there's a little button that says 3D. This opens our three-dimensional viewer. So this is going to start us out with sort of a default three-quarter view of that same terrain model. And we can tilt that down. You'll see this one happens to be pretty flat. And if we take a look at the exaggeration factor, we are zoomed out quite a bit here. So we're looking at a pretty good swath of the earth. What we might do is turn a little bit, and we can see some of that terrain pop out of the screen. So you'll see that. We turn it on its side, we get some of the hills. What I'm actually going to do here is I'll just move over to a particular place. We can zoom in and get a little more localized view. So we turn that right on its side. There we get a much of the localized terrain. So this is a fully interactive viewer. You're not just stuck in one mode. What I'm doing right now is I'm left-clicking and holding, and I'm just dragging on the three-dimensional controls that you'll see in a lot of 3D environments. We can use the mouse wheel to zoom in and zoom out. That's what I'm doing right now. I'm just backing out on that mouse wheel. We can click and pan with that center mouse wheel as well. So we can zoom and pan all with mouse control, fairly simple. There are also these controls up on the toolbar for simply adjusting the view, and this is the entire render now, so we're rendering a slightly different piece. You'll see that progress bar at the bottom of the screen updating as we zoom around to the different portions of the map to get some different data on screen. And the white area that we see around the edges in that 3D view, that is showing up because of the area that we're looking at. I'm just going to move the thing I'm talking about. The white area is the edge of the other map data, basically, where we have null data out here. So we want to get rid of that white, close out viewer, and pan into a little more specific area. So you'll see our screen populated with map data. As we render that 3D view, that's going to be, there's no white edges. So those white edges are just from our map screen where we have null data. So the 3D viewers there, we're going to be coming in and out of this 3D viewer. I'll be pointing out a few different things as we load some different pieces of data in there. And this is going to be used both for our terrain models as we have loaded in now. This is going to be where we can take a 3D view of vector layers. So either just simple extrusions of vector files that we're going to be looking at. We're going to digitize some of our own shapes that we're going to overlay. And as well 3D models. So if you actually have stuff coming in say, Esri formats with what are known as multi-patch files, you can load those in. Some folks are working with another very common format called Collada files. You can drop those right in, AutoCAD formats, any of those different vector formats that we can support in here for display. Those are going to come right into the 3D viewer, and they can actually be used in analysis as well. So we're going to be getting into some of those topics as we go along here as well. So we're looking right now at a single terrain model. So this is actually kind of easy. We have our data already prepared for us. There's another way we can start off in here, though, and that's for those of us working with LiDAR data. So where we don't actually have a fully defined surface, but we just simply have a point cloud that's been collected. And this is data that's coming along all the time. There's more and more LiDAR these days. So what I'm going to do is just clear out my map there. And to do that, I'm just simply using a keyboard control shortcut of Control-U to clear out the map. And I'm going to open up a different file. So I'm going to grab onto a piece of LiDAR data here. So this file is a little sample of an area on the outskirts of the city of Denver here in the U.S. And when we load in LiDAR to handle that data, at the very top, it's going to ask us how we want to load it. If we want to work with a point cloud, which is going to load that in as essentially a vector layer of discrete points, or we can automatically create an elevation grid, which takes a little bit of analysis. And what that's going to do for us is create the that we were just looking at. So it's actually going to create a continuous raster-like surface covering all of the areas that we're in. So first, I'm just going to select to load that in as a point cloud so we can see the differences as we work with those. And because of that, I don't need to worry about my elevation grid option creation there. And as well, at the bottom, we have all these different types of classifications of the point returns in the LiDAR file. For those of you maybe new to LiDAR, each individual point has what's called a classification, and it tells you what that particular point is. So you'll see there's a number of different things we can identify in there, things such as the ground layer. That's what we would use to create, say, a bare earth surface model. We have areas of vegetation, low, medium, and high. So that's going to cover stuff from low scrubby bushes to tall trees, buildings, and a number of other pieces, as well as some open fields down at the bottom that were sort of left open in the specification for various other purposes. I'm just going to bring in our whole file here so we can see the whole surface that we've got. And when we bring that in, we're going to see a similarly colored layer come in, and we can fairly intuitively pick out where we have some building shapes. We have some sort of hard lines in there. We've got some power lines making a stripe down along this area that's actually a highway down here. You'll see some buildings and some trees and such. And if we zoom into a particular area, we can get another little farther apart. You'll see that this is actually still a discrete point cloud. If we render that into our 3D viewer, this will create all of those discrete little points. We can see those points sort of floating in space, and I had just turned up my exaggeration a moment ago as we were taking a look at that first layer. Since it was so large, I can turn my exaggeration back down to a level of 1 here, and that's not going to stretch out my elevations now. So we can more clearly see the surfaces created by some of those buildings. Take a look at that in top-down. We have a fairly obvious display of some trees, some structures, and some main buildings here. So to actually work with this as an elevation model, what we're going to have to do is turn that into a grid. And to turn that into a grid, we have some options for that under the control center. So we can either grid that layer as we load it in, or we can grid the file after the fact directly here from the control center. So what I'm going to do is simply right-click on that layer, and we'll see there's an option to create an elevation grid from 3D vector data. And the 3D vector data there is really the key. This happens to be a LiDAR file, which is just one type of the many types of vector data we support in here. We can do this starting off from contour layers or simply distributed points that you've collected around an area and create elevation grids from those as well. So I'll create that grid surface. What I'm going to do is allow the application to automatically determine the best spacing to create that grid. So essentially what we're going to be doing here is sampling all of those points and creating a triangulated network, sort of the standard way to create surfaces in there. So I'm just going to let Global Mapper do the work for me here to figure out what the best spacing on that is, and it's going to come to that from how close my points are together in the file. We have some options for if we want to create a gridded elevation, if we want to create this as tiles. That might be useful if you're working with a very large area covered by high-density LiDAR point clouds. And grid bounds. We can focus on simply a smaller area if we want to just create a localized terrain model for that. We can narrow that down by simply drawing a box on the screen. And I'm going to do that just in the interest of time here. So I'm going to focus on this area around these buildings. And when we hit OK, it's going to start doing that triangulated surface. So that happened fairly quickly here because, again, I did focus on a fairly localized area. We could do this whole file without a whole lot of trouble. If you're working with very large, high-density clouds, it's not going to take a few minutes to get through that because it is actually a pretty rigorous analysis when you're dealing with millions and millions of points, as is common in a LiDAR point cloud. So now you'll see the view looks very different. It's much more solidified, and we can actually surfaces in there that we couldn't really easily pick out when we were just looking at the LiDAR point cloud. What I'll do here is I'm just going to toggle this on and off. Take a look at the area on screen here with those buildings. I'm just going to toggle that off. You can see how much more definition we get by putting that into an actual surface model because now we can apply things like hill shading to that model. And some of those things we're going to get to under the options for a particular elevation model. You'll see there are some options we have there for the display of those models. We have some options around the intensity of the colors that are going to be displayed. We have some options around translucency, how the elevations are going to be displayed, and there's options in here on hill shading as well. So there's a number of different things we can do specifically with the rendering of those grids. And I'm going to come back in here in a minute to take a look at feathering between a couple of disparate grids if we have grids that don't quite have the same grid spacing, if we want to smooth some of those out. So there's a host of options in here around shading. Those, again, that drop-down shader at the top, we could change that up to a number of different options to suit your needs. So because this is now a surface, we are free to do some of those analysis functions that we're going to get to in a little bit here. Things like the view sheds, things like modifying the terrain if we want to flatten some of this stuff out. You can see that because we created our surface on all of those classified LiDAR points, we actually have the buildings showing up in here. We have some cars in the parking lot between those buildings, and you'll see all the trees. If we wanted to create that bare earth model we were talking about and sort of smooth out these areas, what we might do is load that data and filter it out to only show the ground returns in our LiDAR file. So again, since we have that surface, if we pop that into our 3D viewer, that will run for us a differences here in how we take a look at those LiDAR point clouds. You can see those are still discrete points. We can actually look through the model in the areas over here on the outside of the screen. And in the center of the model here, we actually have solid surfaces for those buildings. You'll see the triangulated surfaces for those being used to create our surface layer. You'll see those discrete points in there because I am still a grid. What I can do is in our control center, I can actually come back and turn off the LiDAR point cloud itself. And then if we render just that 3D surface, you'll see the image is going to get a lot more solidified, and the colors are a lot more pure because we are now just displaying that particular surface. So we can now very easily see things like the trees surrounding the buildings themselves, and then in fact even things as small as cars and small low bushes, all various landscaping features. So that's how we get from LiDAR into a surface model. And again, that same process applies if we were going to start off with something like a contour layer, or even just if you have your own triangulated network, we can create a surface directly from that as well into the 3D view. So I'm going to close us back out of the piece of data we're looking at here. And this time I'm actually going to load in a full collection of data. So I'm going to open up a workspace that I have already prepared. And this goes back to some of that data we were looking at in the very first view. So here we'll see I've got some raster base, some imagery, draped on top of a couple of different elevation layers. So let's take a look at what we've got in our view here. So in the overlay control center, I have an aster elevation layer. That's that very first layer we looked at. So you'll see out around the outside of the screen there. There's that elevation grid we were looking at. I actually have another elevation grid on top of that. And this is derived from a different source. This one is derived from the U.S. NED data. That's the National Elevation Data Set provided by the USGS here in the United States. On top of that, I have created a map catalog file, and that's map catalog is a global mapper format that allows us basically to store a collection of raster tiles. And so what I have here is a map catalog of about 12 different tiles at about 1 meter resolution. This is derived from the U.S. NAPE imagery sets. So each of those three types of data that I just mentioned there, the NED data, the aster data, and the NAPE imagery specific to the U.S. here, those are all online data sources. So real quick here, I just want to point out some of the connections we have built into those. Up on the toolbar, you'll see our little globe icon. Under the File menu, you'll see an option to download online imagery, topo, or terrain maps. Those all go to the same place there. So that little globe icon on the toolbar, the download online imagery selection under File, and as well on the main screen that you start out with, there's another option there to directly download online imagery. Those are all going to launch into our online data source collection. And what these are is basically direct connections via a number of different types of services. We very commonly connect up to things like web map services, web coverage services, various tile sets and such. And these are collections of data that are available for all different purposes. So you'll notice there's sections specific to worldwide data. There are sections specific to U.S. data. We have topographic maps. There's a number of different pieces in here. We categorize these in a few different places. So you might see stuff listed under the imagery section that you will also see specified under the world data section, such as the world imagery layer and such. So there is a little bit of duplication in some of these because multiple categories make sense, but it is pretty easy to find what you need in here. What we can do is select a particular type of data. So let's say I'm looking for some terrain data, and if I were interested in downloading the aster data set, this colorful one around the outside here, that's the option that we have. So right under terrain data, you'll see the aster GDEM set. Farther down, you'll see that U.S. National Elevation Data Set. And then there are some other links in here that you'll see that are tagged premium content. And those are available through partners that we have through special arrangements with companies such as Intermap, which is a great provider of very high-resolution terrain models. Those are, again, additionally premium content that you can optionally subscribe to and get some extra content beyond the free data that we have in here as well. So there's connections in here to things like Intermap data. We have connections into spatial energy data sets and a number of different third-party providers for some of these. So the collection that I have on screen, again, is derived from the US NED and the ASTER GDEM collection. I've downloaded those through this service and exported them out to localized files that I can work with online. Basically, I'm just trying to save some bandwidth here since we are streaming over the web connection today. And what I'll do here is I'm going to turn off my raster catalog, and I'm going to turn off some of those vector layers that I have that have some of that extra culture data, our roads and town lines, things such as that. So if you notice in the center of the screen, I have a much higher resolution version of this grid. And to make this real clear, what I'm going to do is just sort of zoom over a little bit and focus on this particular corner where we can see the seams of those two different elevation surfaces. It's a very obvious difference. The image that I have sort of in the lower left of the screen, that's the collection that came from the US NED data. That's a very high resolution set. That is down at about 10-meter resolution. So those are about 30-foot pixels in our elevation grid. The ASTER collection, since it is a worldwide set, it is a lower resolution set. And those are at about 90-meter pixels in our elevation grid. And so there's a rather obvious difference where we hit the seams of those two collections. And if we're trying to do some analysis, we really kind of need to smooth that out a little bit. And feathering, we can actually blend between those two surfaces. What we can do is in the overlay control center, very simply, we just right-click on one of the layers that we want to feather out. I'm sorry, not a right-click. We're going to left-click on that to select it. We're going to go into the options for that layer and back over to that feathering tab that we explored a little earlier. So the feathering, what that's going to do for us, I'm just going to move this over to the side of the screen so we can see what's going on underneath. And I'm going to select to feather the edges of that layer. So I'm going to feather all 4 of those edges of our US NED data. And you'll see there's a border size, how big the feathering region is going to be. So in this case, we're going to feather over 100 pixels in that elevation grid. And all we have to do is click Apply down at the bottom. And that's going to blend those two surfaces into each other. It's going to smooth out some of the lumps that we see, sort of the jagged edges as we hit the edge of one of those grids and blend it into the other. That's going to smooth it out for things like analysis when we actually go do some of the things like watersheds and viewsheds, lines of sights, cuts and fills, all those sorts of things for us. So that's how we combine 2 of those different data sets. If we actually want to make that feathering persistent, what we can do is use another operation. I'm just going to say OK to that. And there's another option under our File menu where we can actually combine the different terrain layers that we have on screen. I'm not going to go into that right now. It's a fairly simple process, but it does allow us to combine those elevation layers. Can be done to unify disparate sets, as well as some other kind of interesting analysis things where we can add them on top of each other. So now that we've got our surface a little bit cleaned up, let's bring some of that other data back in here. So we've got a nice raster layer that we can superimpose over the top. Let's just pan back down into our map and see what's going on underneath there. And I'm going to come down to an area here that we have a hill underneath in our elevation model. We can turn that off and see that we've got a pretty good hill there to work with. Turn the raster catalog back on, and we have our sort of 2D top-down mode. So I'm going to zoom in just a little bit more. What I'm going to do here is give us a little more interesting area to look at. And now we can take a look at this in our 3D viewer. So let's take a look at the raster being draped on top of our 2D 2D view. And again, since we are looking at actual terrain here, you'll see the view, if we turn that on its side, this is a fairly rolling area. Since we're looking at a pretty wide view, some of those elevations show up, but they are pretty shallow hills. So what I'm going to do here is go back into our 3D view properties. That's the little gear button on the far right of our toolbar, and let's bump that up. I'm going to make the exaggeration up to about 5. So this data here is located in Maine. This is nearby where we are. And so I'm just going to bump up the exaggeration so we can very clearly see some of those different hills, and we can pretend we're somewhere a little bit closer to the foothills of the mountains with this data. So again, our 2D raster imagery, simply draping on top of that surface grid, and it doesn't matter where that surface grid comes from, whether we started off with LiDAR or if we're loading in one of those remote elevation surfaces, or if we're starting off from some other analyzed grid, such as a contour file or a vector layer. So we have our sort of our 3D work environment here. What I'm going to do is turn back on those extra layers that we have, some culture data. We now have some roads, and the roads are going to be our lines in orange on the map, and our town lines in grading political townships here are the red lines. Those as well will drape into the 3D viewer, simply right on top of those surfaces. They don't have to be 3D files up front in order to drape into that 3D view. And what we can do is start taking a look at some of the given features that we have in here around analysis. So if we want to just quickly do some stuff like give us a very quick idea of stuff like where water happens to be in this view. The terrain models don't actually really respect anything where a water height is. So if we want some of that reference in our 3D view, we do have some buttons on the toolbar there. We can simply toggle on and off a water plane at a fixed elevation there. You'll see the blue coming in underneath our terrain model. What we can do is use the buttons on the toolbar there to increase or decrease the water level heights, and that's going to show us where that's going to intersect with our terrain under the 3D display properties. The water level can be arbitrarily set wherever you like it from that view, as well as toggled on or off from this dial. We simply uncheck that, and you'll see our water level disappear in the background view. So that will give us a little more reference, and we can also start interacting with some of the lines and areas and all the different shapes and models. We can start bringing some more data in here. So what I'm going to do is grab onto my Digitizer tool. That's the tool on the upper toolbar here. It looks like a little pencil. That's going to enable some of those digitizing functions on the lower toolbar there. So that's the whole Digitizer toolbar. We can use this to interact with some of the areas that we have here. So I've just selected a stretch of road on this file. We can do stuff like right-click on that segment of road, and we can do a very quick path profile on that. So this will give us an elevation profile along that stretch of road. So in this case, the road layer itself is only a 2D layer, but because we're filling in the terrain model underneath it, it gives us a very easy means of establishing a path profile for that. So the path profile allows us to see exactly where the elevations are on that. These can be stored as images that you can superimpose on a print map if you're creating one of those. And also, as well, as we scroll from left to right here, you'll see my cursor. As I move from left to right, it gives us the horizontal coordinate for the corresponding spot snapped onto that road feature. As well as on the main map view, you'll see a little red X set of crosshairs moving along to the corresponding region on that line segment. At the bottom of the path profile tool, you'll see a couple of the analysis functions that we have here. So we have a line of sight calculation and a cut and fill volume calculation. So So if we wanted to do a line of sight, we're actually going to need to supply a little bit of different information. We're going to need to have a start point and an end point. So we need to have 2 points drawn across our map. I'm going to come back to that in just a minute. But what we can do right here is a simple cut and fill volume calculation. So let's say we're establishing this road. Let's say the road isn't actually here yet, and we're going to have to do some excavation. So maybe we're going to have to do what's called building the road. We're going to dig out the roadbed, and we're going to bring in some various aggregates and gravel and pack that down and actually build up a structured road surface. If we need to know how much we're going to dig out going along, following that terrain, we can do a cut and fill volume calculation. So let's say we're going to make our road, do this in feet since we're in the U.S. I'm going to make the corridor diameter around our line. Let's say I'm going to make that about 20 feet across. So our road is going to be 20 feet wide, and we want to establish our volume units. So what we're going to be talking about in terms of units for dirt, we can select whatever volume we like there. We can optionally create a new line or area feature that has the output of this volume calculation attached to it. And what we need to do simply is select an elevation or a depth. So in this case, I'm going to say, let's say, for example, we need to dig out that road bed 2 feet. So I'm going to say, let's dig that out to -2 feet relative to the ground. So I'm going to use the same base height for all vertices, so relative to the ground as opposed to elevations relative to sea level, which is another way we can specify cuts and fills in here. So we're going to dig that whole road bed out 2 feet with a 20-foot diameter around the line segment that we've selected. We select OK on that, and it tells us we're going to have to dig out 5,700 cubic meters of dirt in that area. So we're going to have to figure out where we can haul 5,700 cubic meters of dirt off to, and we're also going to have to come up with that amount of fill to put back in over the course of that line. It gives us things like the fill surface area, the cut surface area, how much we're going to be digging out and filling back in some of those various places as they interact with that terrain model. As we do that, the volume calculation, you'll see the extra red line gets traced in on our screen such that we can tell exactly where the digging operation is going to happen to on the graphic relative to that surface. Since we only did a shallow cut here, it's going to show up almost right on the surface there. Our pixels are overlapping. If we were doing a deeper cut, we'd see that red line go a little bit deeper into the surface. Because we selected to create a new feature from that, we can actually add some attributes to that. You'll see all of the cut and fill area are being pasted right in as the attributes on that line. And we just need to give that a name. I'll call this our road bed. And then we have a new line segment that is drawn on our map representing that portion of the roadbed project, and we can save that out as its own discrete file. In our Overlay Control Center, we're going to see that show up in our user-created features layer. And that can be moved elsewhere if you want to join that into something else. So that's one of our simpler types of analysis. The path profile and the line of sight can both function directly on lines there. If I do something like a path profile, simply digitizing, so there's a path profiling tool up on the upper toolbar there. We can also simply do a path profile on a straight line that we draw across the surface. And that's going to give us a starting point and an ending point. You'll see there's no individual little nodes along the surface because I don't have vertices along that line. I just did a quick little 2-point line here. And with that 2-point line, I can do a line of sight calculation from the start point to the finish point of that line that I just drew. So if we want to do a quick visual line of sight on this, let's say I'm standing at one end of the line, so I'll put an elevation of about 2 meters off the ground for a tall person where their eyeball height would be off the ground. And let's say we're looking to the other end of that line. We're maybe going to propose putting a tower at the other end. So let's talk about putting a 30-meter tower above the surface at the other end of that. We have some options in here for Fresnel zones. That's for those of you working with broadcast transmissions. So things like radio waves, working with Earth curvature. There's a lot of complexity that goes in with that, and there's the settings where you're going to be able to use the 4/3 coefficient as well as calculate your Fresnel zones. We can ignore those settings if we're simply looking for a direct visual line of sight. So I'm going to look for a visual line of sight here, 2 meters off the ground, looking at a 30-meter tower at the other end of my line. As we OK that, we'll see the line of sight is added into our path profile on the view. And we'll see if we stretch that out a little bit, we'll see there's going to be a little point of contact in there. So we're not going to be able to, actually it looks like we are. It's going to be really tight here. There's a little red spot that's showing us our minimum clearance. Oh no, and I looked at that wrong. That is actually minus minimum clearance. So we're just barely not going to be able to see the tower at the other end of our line by about 0.3 meters. So we just barely missed the top of that hill, but we can't see to the other end of the line. That's our line of sight function in there. So again, those can get a lot more complicated as we're talking about a line of sight broadcast or visual line of sight in there as well. So the line of sight and the cut and fill both interact with those surfaces along a direct path there. More advanced, we can actually interact with the entire area. So what we can do is something like a view shed. And the view shed actually allows us to plop down a tower somewhere in the middle of our area here. So what I'll do here is I'm going to stick a tower on the top of our hill here in this area that we've got some cleared out trees. And you'll see there's a number of options here for what we're going to be doing with this tower height. We can apply a transmitter elevation. So the transmitter is the tower that we're going to be locating at the center of that. If we want to do a visual line of sight here, maybe we're going to have a 30-foot tower on the top of that hill. We can do a visual line of sight about 2 meters off the ground for an eyeball height if you're really tall. There are some other options where we can fine-tune that. And these other options are going to be probably a little more useful to those of you doing things like radar or cell phone network planning or other radio network broadcast planning. We can set the view angle there so we can sweep around in particular directions. And again, all of those options that we have for analyzing the broadcast frequencies, such as the Fresnel zones and the Earth's curvature for the 4/3 coefficients. We have a view radius that we specify, so our line of sight can be cut off. That basically saves us a little bit of time in the processing, so we're not necessarily trying to get a line of sight on something that's obviously too far away. So I'll do a little narrow one here. I'm just going to do a little line of sight calculation down at about a 3-mile radius from our tower. And we can also specify a minimum radius, so don't bother looking at areas that are too close to that central tower. I'm just going to leave that set to 0 so we can get the full radius around the edges. And then the sample spacing. This is a really big one. For folks that are doing coverages over large areas, if you're talking about things like radar mapping or cell phone mapping coverage, you don't need to have this at an incredibly granular level. You're going to be able to turn that up. And if you're doing a very large area at a very fine sample spacing of just a couple of meters, it's going to take you a while because it has to do a whole lot of line of sight calculation. If you're doing a smaller radius, obviously you can really turn that down to a much finer resolution. Mine is about 10 meters, and that's going to be fair for the purpose that I'm doing here of this small area. And there's, again, those other options. In this case, I'm doing a visual line of sight, so we can actually ignore some of those settings like the Fresnel zone clearance and such. If we're going to do multiples of these, there is a display color. What this is going to do for us is draw an area on the ground. So if you're going to be doing a couple of these to see what various transmitter heights would do, you may want to go in there and change some of your color settings as you get multiples of these on the screen. So I'll just OK my view shed. It's going to perform the elevation analysis there for me. It has a couple of stages that you'll see go by. One is figuring out the elevation grid that it's going to be working with. The next is actually doing the visibility analysis that you see then. and then once it establishes the visibility analysis, it's going to re-render the screen and draw for us a new series of areas, mapping out all of the areas that can see that transmitter location from the sampled area on the ground. So you'll see we're going to cut off at that 3-mile radius around the edges, and the red areas here are indicating the areas where that tower site would be visible to somebody standing on the ground. So again, if we wanted to make a comparison of that, we could go right back in here and do another view shed. We could add a second tower, maybe give it a different color, and we could stick that right on top of the view shed area here, and we could see how those different views are going to correspond. One project I've been doing with this recently is a bridge project, where they're proposing a bridge that could be of various heights. So one bridge possibility would be with a road deck 80 feet over the water body, and another proposal is only 40 feet above the water body. And so in that case, we would come in here and simply do 2 view sheds. We could plop down another view shed analysis and change that transmitter height. Okay, let's double the transmitter height, and I'm going to change that color so we can get a good contrast on our screen. I'm going to leave all the rest of the settings the same. I'm just going to see what the difference is on that increased transmitter height, and we'll do the same analysis over, and we can get a very quick visual comparison on the areas that were going to be affected differently, so the increased visibility of those areas. One thing we haven't done yet that will also affect this is if we drop in additional models. So you'll see after we draw those areas in, we have our green model showing up on top of our red model. We can see some of those disparate areas. We're picking up a little bit of extra height, but not quite as much as one might think on that extra tower height. So just a little bit around some of the edges of our view shed. And then again, something we might do that could have an effect here is bring in some of those different model types. So to do this, what I'm going to do is I'm going to zoom in to a little focused area down here, kind of next to my tower. And what I'm going to do is use my Digitzer to simply draw a little footprint on the ground. So I'm just going to do a nice simple box here, and I'm going to call this a building. So let's say I have a building of some sort on the ground. I'm going to add an attribute to that building that's going to give it an elevation. So let's say I put a 50-foot building. It's going to be a pretty tall building on the ground in this point. So now that little box I drew, it's a building footprint. It's going to have an elevation of 50 feet above the ground there. As we work with that building, we can turn that into the 3D view here. So as we render our surfaces on there, what we can do is use our 3D view properties to treat 3D vector elevations as being relative to that terrain surface. There's this little checkbox in the vector display options. And then the box of that building being drawn on the surface. Now in this case, I've been a little bit sloppy in my building definition. You'll see the roof of that building actually corresponds to the slope of the terrain. I plunked this down in a little bit of a sharp valley here, and so the roof of my building actually has that slope in it, but you'll see the extruded lines showing up. Let's see if I can get this a little better. If I turn it sideways there, we'll see that building being extruded out from the terrain surface. An alternate thing I could do in here is I could apply an absolute elevation to the roof of that building height. We could come back out to our main screen here and see where our elevations are falling in there. So if I very quickly turn off my raster catalog, we'll see that we're falling in sort of the mid ranges of our elevations with those green areas in the back. Turn off my view sheds, we can get a real good idea of that. So if I want my building to fall into a higher elevation, I can also specify that with a very specific absolute elevation. That's simply by right-clicking and editing on that selected feature, and I can change that elevation. So let's change that elevation to be at an absolute elevation of, let's say, about 120 meters off the ground, off of the sea level height here. So I can apply that elevation. We can go back into our 3D view. And once our 3D view renders, what I can do is now I'm going to toggle that off. So now instead our 3D vectors, their elevations are going to be relative to an absolute sort of that sea level height. And then you'll see the top of our building is actually squared off in there. So regardless of what the terrain is underneath it, the top of our building is going to be flattened off at that height. So now that we have that 3D model dropped in, which is a very simple one, if we come back out, zoom out a little bit so we can see where we were dropping our towers, I'll turn our view sheds back on there. So there's our first view shed. There's our second view shed, and that's going to be coloring, it's going to be tinting the one under it. That's why it seems to turn green there. If I plunk down in that same location, we can do that same view shed analysis, and this time we're going to end up seeing a shadow from that building in our output. So all of those 3D models that we drop in, if you're going to be hand digitizing those yourself just for some quick building footprints, or if you're going to be loading in pre-designed models from, say, a Collada file or an AutoCAD file, all of those different things in there are going to be affecting our view. So we can toggle off some of those objects, and those building footprints will affect what we have in our terrain model. So that's some of our view shed analysis, and some of the other tools we have in there. Just zoom out a little bit, get a little clean piece of map. I'm going to scroll us over to a slightly different piece of terrain. And we also have some functions in here under the File menu for watersheds and generating contours. So these are our other types of analysis here. These are the last things we're going to come in over the hour. So we can do a very simple contour generation for some of these. We can focus on a particular area. If we want to narrow it down, we can set our contour intervals to restrict those to particular areas on, particular elevation ranges as we move between some of those heights. So what I'm going to do here is draw a box on screen just to very quickly narrow this down so we can do this one very quickly. So I'm going to focus just on a localized area here for my contour generation. We're going to make 10-meter contour intervals in that area. And as well, we can crop the elevations if we want to only see specific contour ranges, and as well the resolution of our analysis. And that's going to be really used to speed up the process if you're doing a very large area. So we'll OK that contour generation. You'll see very quickly in drops those contours that we've generated, and that as well gets added in as its own layer in the Overlay Control Center. So we can export that layer separately if we wish. You can pump that out as a shape file, CAD file. Any of those 60-some-odd vector formats that we have in there can be written out as a contour. Again, we can go the other way. You can start off by bringing in a contour file, and we can then grid that file as we did with our LiDAR data at the beginning. But that's a very simple and powerful way to create some of those contours. There's a number of options in there that we just don't have time to get into today about smoothing and the various major lines. You'll see the major contour intervals and the minors. There's a number of ways we can fine-tune those contours. So again, I'm going to pan us over to a clean section of terrain here, and we're going to take a look now at a watershed. So basically, if we drop a bucket of water on the ground, which direction is that water going to flow? That's a watershed calculation. So the watershed is going to calculate for us a drainage network as well as areas on the map that allow us to see where water is going to flow together and then form streams. And so there's a number of very advanced options in here as well. What we're going to do is watershed bound. I'm going to narrow that down since I have a pretty big area of terrain loaded in here. I'm just going to draw a little box and we can do our watershed in that area. Some of those various options, again, the resolution of the drainage network that we're going to analyze. If you're doing a very large area, you're probably going to want to pump that up to a higher, a larger pixel resolution, that is, so a higher value for your resolution. There's various depths that we can control in here, the depressions that we're going to fill in as those streams form and they float along. And again, another bunch of just a whole lot of very complicated things that we can add in. Whether or not we're going to trace the flow from a selected point, which is a water drop analysis, so I basically flow from a particular point into those streams and water bodies that are going to form. So we can fire that off. What it's going to do is analyze that terrain, and again, all these polygons that are going to be drawn for us on screen, all of those area features, the similarly colored area features are going to be flowing into those streams that are forming along roughly the middles of most of those. Those are where our troughs are going to form to create streams. And then they're going to flow again into sort of larger and larger water bodies as they go downhill. Those can also be interacted with in the 3D viewer. The watershed polygons themselves aren't usually so useful in the 3D mode. What we might, to get into the overlay control center there, what we might actually do is turn off the watershed areas in our view and just reduce that to the particular streams that we see. And we can take a look at that in our 3D viewer, and we'll see how those streams collect into the various troughs of the terrain. So those streams are going to pool together, form streams as they flow downhill into those larger water bodies at the bottom of the hill. Those are distinct vector lines, as well as the areas that are created for the individual watersheds themselves. And then again as well, if we want to do water drop analysis, we can do that based on points that we have in here as well. So that's going to wrap it up for some of the topics that we're looking at today in various terrain analysis functions in here. What I'm going to do is take a quick look at some of the questions that have come along during the hour to see if we have any questions that we want to address with some folks. Let's see here. We have there was a question about adding in brake lines, in particular when we're loading in some of these elevation surfaces, things like LiDAR point clouds as we bring those in. The question actually was, are we going to be adding brake line options? But the answer to that question is that we already do support brake lines. So if you've got 3D data loaded in, so either brake lines, or if you've got some contours that you want to use as brake lines, you can select the layer that has those brake lines via the control center, and then right-click and select to create an elevation grid. That will actually use that line as a boundary to flatten out the data that you're working on. We can actually take a quick look at that using the contours that we just created in here. So what I can do is with my digitizer, let's say I want to create a brake line around this little ring right here that I just created. So I've just selected that little area. If I want to use that as a brake line to flatten out the terrain in that area, all we have to do is right-click, and you'll see there's an advanced feature creation option in there. One of the things we can do is create, modify the terrain. Actually not seeing that option on here at the moment. I must have done something a little silly. Oh, that's what we want to do here. We want to edit that feature. We need to get the elevation in there. The elevation is already set. Okay, Mike, if you're on the line, maybe you want to point me to the specific thing that I'm doing wrong there to get to take effect. And we'll take a look at another question there real quick.
Yeah.
There, Mike? Mike, you're on audio, so you can actually just go ahead and talk.
Okay, can you hear me now?
Yep, you're on loud and clear.
Okay, yeah, you have to create it from an area feature, not a line feature.
Oh, I'm sorry, that's right. What I can do real quick with that digitizer, I've already got it selected. Up on the digitizer panel, there's a little tool to create an area feature from a line feature. So that's what we need to do first. Thanks for the tip there, Mike. So we're going to create an area feature from that line feature, and there's a few options for that area creation if we're going to be combining multiple lines into an area. And so we create that new area feature. So I've got my 80-meter level there as the elevation for that feature. So there's my new area feature. Now if I right-click on that under my advanced feature creation options, I'm going to have the option to flatten out the terrain in that area. So if we select that out, what that's going to do for us is basically create a little subgrid in my elevation model. So if I flatten that out, I'll just deselect that. You'll see it actually flattens out. The shading on that turns similar throughout the area corresponding to the elevation in the elevation shader. And if I pop that into the 3D viewer, once that renders, you'll see the top of my hill has now been sort of cut off there, and we're flattening that out into the plateau. And then above that, the polyline for the next contour up, that's actually still staying in place because that contour line itself is in its own layer. It's going to be floating up above there. So you can use that to plateau off those various surfaces. If you want to do something like, say, smooth out the bottom of a lake or flatten off the top of a hill, things such as that. So I think that's going to wrap it up today. We're going to, I've gone a little bit over my time. I'd like to thank everyone for attending today. If there are any unanswered questions that folks have sent in, we will be following up with those via email after the fact. And again, today's session has been recorded, and we'll be posting that on our website. A notification will be sent out when that is available. And the website is up there on screen now. You'll see bluemarblegeo.com. That is our main website. On the left-hand side of the screen, you'll see a link to webinars. That will take you to our webinars page right here. So again, we'll be publishing next month's topics fairly shortly here in the next couple of days. And you'll also be able to access any of those previous webinars for the past months that have gone by. So again, thanks everyone for attending.